Now that AC electrical power has been established to the aircraft, we can begin the pre-flight procedure, both pilot flying as well as pilot monitoring. For this tutorial, the pilot flying will be in the right-hand or first officer's seat, and the pilot monitoring will be in the captain's seat. I will endeavor to switch viewpoints to illustrate which crew member is accomplishing which checks. The first step for the pilot flying will be to set up the navigation, FMC, as well as mode control panel. To start, we need to align the IRS units. So, we'll come up to the overhead panel and select the number 1 or left and number 2 or right IRSs to the nav position. The on DC lights should momentarily illuminate, signifying a built-in test, and once that built-in test is complete, the white align lights will come on. If we cycle the outer knob on the IRS display panel to heading and status, it will display a countdown until the IRS is aligned. In this case, 0 minutes because we have instantaneous align selected in the PMDG settings. Now let's jump into the FMC itself. To begin, a little nomenclature. The FMC, or Flight Management Computer, is the actual physical computer that the aircraft uses to interface with the navigation systems on board the aircraft. The box you're looking at is the Control Display Unit, or CDU. In more modern aircraft, the Multifunction Control Display Unit, or MCDU. Typically, FMC and MCDU are used interchangeably by the crew when referencing inputs to the CDU itself. On the CDU, we have line select keys labeled 1, 2, 3, 4, 5, and 6 left, as well as 1, 2, 3, 4, 5, and 6 right. These line select keys are used to take data from the scratch pad, the lower portion of the display, and to place it in the categories located next to the respective line select keys. The scratch pad is used to enter data via the alphanumeric keyboard, as well as to display messages generated by the FMC itself. FMC messages can be cleared using the clear key on the keyboard. Let's get started. Select FMC at LSK1 left, and select ident at LSK1 left to begin the pre-flight process. The general flow through the box will be prompted by LSK6 right, which will have prompts leading you to the next page to complete the pre-flight procedure. Starting on the ident page, verify that the model aircraft as well as engine rating are correct for the type aircraft, that the AIRAC data is up to date, and that the operational flight program is the most up to date from PMDG. Next, select Position Initialization, and here we will align the inertial reference unit. We can place the identifier for the departure airport under the Reference Airport tab, and we will see that the prompt to set IRS position is located next to LSK4 right. The boxes indicate information that is required for a successful departure. In this case, the waypoint 0, or alignment point, for the inertial reference system. In other words, the starting point for the inertial system. The easiest way to get this data is select Next Page, select LSK4 left to download the GPS generated coordinates into the scratchpad, select Previous Page, and then using line select key 4 right, paste the GPS into the INS. We can now see that the attitude indicators on both PFDs as well as the navigation displays are now active. Let's continue with the FMS pre-flight. Select LSK6 right to access the route page. We can see that our reference airport, today Payne Field, has been preloaded into the scratchpad, and we can select it into our origin. The destination field is mandatory as indicated by the boxes, and we can fill that with the identifier for Portland International Airport. At this point, select Flight Plan Request at LSK 3 right and select the SimBrief route. Here, as a SimIsm, we can set the payload and fuel to those planned by SimBrief, and then select route at LSK 6 right. From this point, the PMDG CDU simulates that of the real aircraft. The flight number appears automatically, and a load prompt appears at LSK 6 left, allowing us to load the data-linked flight plan. Once the flight plan has been successfully data-linked, a scratchpad message will appear, and the activate prompt will become active at LSK 6 right. Select activate, and then execute. Selecting next page will access route page 2 of 2, and here we can see that the route, the en route portion only, has been uplinked to the FMC. Not included in this uplink are any standard instrument departures, or SIDs, or standard terminal area arrivals, STARS. We must select those manually via the Departures and Arrivals key. Selecting Departures and Arrivals, we can select Pane Field Departures at LSK 1 left, and we can select Runway 16 right. The Pane 6 departure is a vector SID and is therefore not coded within the FMC. Select the Execute key and return to Departures and Arrivals. For Portland, we will be landing on the ILS runway 10 left approach with the Buxom transition from the Crater 2 arrival and the Buzo transition. This information can all be found on the flight plan documentation provided by SimBrief. Select the Execute key and return to the route page. Selecting route page 2, we can now see that our plan directly to Seattle VOR, directly to Buzo waypoint, the Buzo transition to the Crater 2 arrival, and then vectors to Buxom for the approach to ILS 10 left has all been loaded into the FMC. For now, the route is complete, and we can move to the next step of the pre-flight performance initialization by selecting LSK 6 right. The performance initialization can be data linked via the request key at LSK 5 right. Once the data link has completed, we can find the load prompt at LSK 6 left, and the requisite information will be filled out for us. Select Execute, and the pre-flight is now, for the most part, complete. We can verify that the SimBrief information is correct and compares with the paperwork. In this case, the altitude has not uplinked correctly, so we can correct it by typing 190 via the alphanumeric keypad and placing it in the cruise altitude field using LSK 1 right and executing the change. Next, let's take a look at our winds. Once the route has been successfully input, we can go to the legs page, select route data at LSK 6 right, and select wind request. The wind request is in two parts. Cruise wind is input from the legs route data page, as we will momentarily see, and descent winds are input on the descent VNAV page. Cruise winds have uplinked, so we can select load, and once the loading is complete, once again press execute. Descent winds can be found on the descent page. Select descent, forecast, and load. Once the descent winds, in this case for flight level 250, 15,000 and 6,000 feet have loaded, we can select Execute. That concludes the majority of the FMC pre-flight from a navigation perspective. We'll come back once we've received our performance data, and we'll load that into the FMC to complete the pre-flight. However, at this point, we can now take a look at the standard instrument departure, set up our nav radios, and the autopilot mode control panel. Let's leave the FMC on the progress page while we take a look at the navigation. From the nav graph charts that we previously pinned, we can select Standard Instrument Departure and the Pane 6. We can see that off of runway 16 right, the SID requires us to climb on a heading of 163 to an ATC assigned altitude. In this case, we'll say that ATC has assigned us 9,000, and we'll dial in a heading of 163. The bank angle selector at the base of the heading knob should be selected to 30 degrees. The course knobs on the MCP, both captain and first officers, should be set to an ILS or other approach that allows for an air return in the case of an emergency. So, let's take a look at the Pane Field ILS Zulu to runway 16 right. The final approach course is 163 degrees. So we can set this in both the first officer and captain's course knobs. This will just be one less thing on our plate if we have to come back to Pane Field after an engine failure or with a fire. Finally, the navigation radios should be set to 109.3. 109.3 can be set in the standby, and 108.0 should be selective in the active. 108.0, a VOR frequency that's generally not active, will clear the PFD of glide slope and localizer scales when they're not desired. Simply selecting the transfer button will place the ILS frequency into the active. We'll do the same with the captain's display. The transponder code would be input into the transponder as well at this time. The final piece of information required for the MCP setup is the speed. In this case, we'll set it to V2 once we receive our performance data. The final step for the pilot flying pre-flight procedure will be testing the oxygen mask, as well as the autopilot, auto throttle, and FMC message lights, both System 1 and System 2. That concludes the pilot flying pre-flight procedure for the 737 Next Generation.